All right, folks, today we're going to look at using the EOQ or Economic Order Quantity Model. We're going to look at the problem from Part B of project number 2. We're going to look at several different functions and figure out exactly what our economic order quantity is. In other words, what is the best possible quantity for us to order so that we get the absolute best value for our money. We're looking at a very small pizzeria here, Mama Mia's, and she averages about 200 pizzas each month, so she doesn't do a lot of business. We know that the boxes cost us 20 cents each, and each time she places an order, it costs $10 to process. So let's assume she pays herself $10 and $10 an hour, and it takes her about an hour to count all the boxes and figure that out. So she has to figure $10 in lost wages because she's not making pizza or whatever. She also knows she has limited storage space, so roughly 30% of the cost of her inventory is taken up just in storage. Now, the way this works is, let's assume that there's maybe she could do a hot and ready pizza, or she could put a Coke box or something of this nature in there. That's space that she's using as lost opportunity. So we count that 30% as lost opportunity cost because she has to store these boxes. We also know that it takes her approximately 7 days to get the boxes. So let's say she orders them on a Sunday, she'll get them the following Saturday. And to make the math easier, we're going to assume 30 days in a month, and of course 12 months in a year. All right. Now, we got to pull some of this information out here. We need to know the annual demand. We need to know the cost per order, carrying charge rate, cost per case, cost for holding inventory, and all of this to calculate our economic order quantity. So, if we know that we can deliver 200 pizzas each month, that means then we're going to need 200 boxes each month. And if there's 200 boxes per month, 12 months in a year, then our annual demand is 2,400. Our cost per order, we know, is already given to us at $10, so we simply plug in $10. The carrying charge rate is the I, that's the percentage here, the 30%, so we just plug in 30%. The cost per case, we know, is 20 cents. Now, we're assuming here a case and a box are the same thing, so we're going to say 20 cents per case. Cost for holding inventory is going to be I times C. So we're simply going to multiply 30% times 0.2 or 20 cents. So we're going to multiply here cell B3 times B4. Excuse me, times B4, not plus. B3 times B4. And that gives us 6 cents. Now, what that means is that each box, as long as it's sitting on the floor, she has to pay 6 cents in lost opportunity cost. All right? So, now to find our economic order quantity, we're going to use this to plug in here. Q star is the variable that we use for the economic order quantity. It is where the inventory holding cost and the annual ordering cost meet. So Q star is going to be equal to square root of 2 times the demand times the cost per order divided by the cost for holding inventory. So the way we do that in Excel is equals SQRT, open parentheses twice because we have a numerator and a denominator, 2 times the annual demand times the inventory holding cost. We then divide that by the, made a mistake here, forgive me. So it's 2 times the annual demand times the cost per order, CO. And then we divide that by the inventory holding cost. So, the formula you see on the screen here is correct. Square root of 2 times the annual demand times the cost per order divided by the cost for holding the inventory. 2 times B1 times B2 divided by B5, then you take the square root. Now you know you got it right if you get 894 and change. Of course, we can't order 4/10 of a box, so we have to round that number up, and we assume then in our economic order quantity is approximately 895 boxes. At this point, go ahead and save your file. Make sure you don't lose this work. Okay. Now, the next thing we need to do is figure out what our annual inventory holding cost is for different quantities across the board, because we need to draw a graph of all of this. So, now that I have all of this information, I'm going to pull these questions over and put them on the right side. So I've already done that, and I'll just make the screen a little bigger here. Okay. So our inventory holding cost is going to be given here. So we're going to type in cell B10 inventory holding cost. And we're going to go between B and C column and increase that. And our annual ordering cost is going to be the next column, right? Okay. All right. So putting all of this together, we have our annual inventory holding cost, we have our annual ordering cost, and we're going to have our quantities in this column. Now we know that our EOQ is approximately 895. So we're going to go up in volume from 100 to 2,000, counting by 100s. So we're going to go from 0, 100, 200, 300, all the way down. Now you can continue like that all the way to 2,000, or the easiest thing to do is highlight from A11 to A14, highlight the first numbers you wrote, then left click and drag that number down, and you can see that as I drag it down, it slowly increases in quantity. So what it's doing is it's auto-filling each of those numbers, and I want to go all the way to 2,000. Now I picked 2,000 because we know our EOQ is right around 1,000, and that will allow my graph to cross somewhere in the middle. Okay, so my annual inventory holding cost is given as 1/2 Q times CH. So we're going to plug that in as equals 0.05 times Q times CH. Now anytime that you come here to the numbers that were given to you in the problem, we're going to make that an absolute reference. On a Mac, that's Command T. On a PC, it's F4. So we want to make it 1/2 QCH. 0.5 times the quantity times CH. So if I order 0, obviously my inventory holding cost is going to be 0. Then I simply autofill all the way down. And if I order 2,000 at a time, then I'm going to have to pay 2,000 times 1/2 of 0.06, which is going to be roughly $60. My ordering cost, however, is going to be higher. Now, let's figure that one out. So we're going to say equals, and you'll notice here that the demand divided by the quantity times the CO. So we're going to say demand, and again we're coming to our givens, so we're going to make that an absolute reference, divided by the quantity times CO. Make that an absolute reference. Now, at this point, those of you who are more astute can notice that we're going to have a problem with this one. And that's because my quantity here is 0. And if I divide by 0, I'm going to get an error. So, when I hit enter, the first thing I get is divide by 0 error. But that's okay. I simply autofill all the way down so that I get the numbers that I'm looking for. I'm going to take these numbers and I'm going to turn them into dollars, just like I did this one. And then I'm going to come to column 11 here, row 11, and I'm going to right click and delete. So that I start at 100, go up to 2,000, and as I increase the number that I order, my holding cost is going to increase. It makes common sense, right? The more boxes I order, the more I have to store them. The more I have to store them, the more lost opportunity cost I have. My ordering cost, however, goes down dramatically. This is because the more I order at a time, the fewer times per year I have to order. So what we want to do is balance how much it's going to cost me to hold them in inventory versus how much does it cost me to waste my time ordering boxes. And you'll notice that somewhere right around here is where the numbers start to shift. Below 900, it's lower for me to hold more. Above 900, it's lower for me to order more. And that's because we said that our EOQ is 895. So if we were to right click, insert, type in 895 here, we'll see that our numbers are almost exactly the same. Now they're slightly different because we know the actual EOQ is 894.42. That's the reason for the 3-cent difference. Last thing we want to do with this is graph it. So we're going to highlight from A10 down to C31. We're going to insert, and if you go to recommended charts, you'll see that you have several different charts that you can use. Okay? Now, the problem with this is that we actually need a line chart. So we're going to go back over here, look for our line chart, and use the very first one. Okay? Now, while this looks great, all right, we'll notice that there are some things that need to be fixed. First thing right off the bat, you probably cannot read this legend at the bottom. Well, I'm not going to be able to read it either if you leave it in this direction. So we're going to highlight these numbers, right click, format axis, and then you can go to text options and you can change. Now the easiest way to do it obviously is just to right click, go back to the home button, and increase the font size. Make it at least 12-point font, but the larger the better. Do the same thing with the y-axis, increase it and make it the same size. We'll make it 16. And for my chart title, just type EOQ for Mamma Mia's. Okay. Now you'll notice that at 895, that's where the two numbers cross. We right click and add a data label, and it tells me that my cost here is $26.82, and that's what we were looking for. So I know that this is where I have minimized my cost. Anything above that in my numbers, anything above that 895, 900 range, and my numbers are going to continue to go up for the inventory holding cost. Anything below that, and they go down for the ordering cost. Now, there's one other line that we need to add on here, and that is the total cost curve. Okay, so the way we do that, I'm going to get rid of these guys here. The way we do that is by simply adding a total cost curve here. And that's going to be, total cost is inventory plus ordering cost. Total cost is inventory plus ordering cost. Okay. And then we autofill from there. And we see that as we approach 895, the numbers are going down, 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 down. But that as we increase, the numbers continue to go back up. Well, that's what we don't want. So if we were to add that total cost curve in there, we're going to right click, all right? We're going to go to format, okay? Now what we need to do is add these extra numbers. So all we have to do is highlight this over, pull that one over, and it will add that gray line in there. Let me do that one more time so you can see what I did. When I click the box here, it highlights the data that I have. I've added a column. So what we need to do is add that, and all I have to do is left click the little blue dot, right click or drag it to the right, and it will now include my total cost curve in the equation. You'll notice that the minima of that line is at $8.95, so I can click twice to highlight just that dot, right click and add data label, and it will tell me now that my total cost at this point is $53.67. Okay? Now, at this point, save your data because we don't want to lose what we have. You now know how to find the EOQ and how to develop your cost curves for a graph that makes it easier for you to be able to develop your product. Alright, the next thing I want to do is tackle answering the questions that were actually in the project. So, question 1, what is the economic order quantity? Well, we look here, we round that up, and we see that our number is $8.95. So for answer number 1, the answer is $8.95. Next question is, what is the reorder point if we have no safety stock? And then it says, what if we want to have 20 boxes of safety stock? Well, our reorder point is the demand times the lead time. Now we know from the problem, let's go back to the problem here, and we know from the problem that the lead time is 7 days. We were given that in the problem. The lead time and the demand have to be in the same units. We know that we have 200 pizzas per month, or 2,400 per year, and there's 360 days per year. As a result, our D, small d, weekly demand is going to be given as 2,400 divided by 360. And that means then we're selling approximately 6.7 pizzas per day. So far so good? All right. Now, I'll move this down just a smidge. If this is my demand and my lead time is in 7 days, then my reorder point, which equals D times L, is going to be equal to D times L, right? Now L, we knew lead time is 7 days. So 6.67 times 7 is going to give us approximately 47. Now what this means is when our inventory gets down to 47 boxes, we're going to order more boxes. So our reorder point with no safety stock is 46.67. If we want a safety stock of 20 boxes, all we have to do is add 20 boxes to it. Right? So we're going to come here and we're going to say with safety stock, and then if we're going to say equals this plus 20, and make it where you can actually read it. Sorry about that. All right, let's go through that one more time. We got small d annual demand by taking 2,400, which is our annual demand, dividing it by 360. We divided by 360 because we knew from the problem that there were 360 days in a year. Now, that means there's 5 days that she's not open. Our reorder point is that annual demand, or excuse me, that daily demand, 6.67, times our lead time of 7 days. So we get 47 boxes. Now we're rounding that up to the nearest whole number because we can't order 46 2/3 boxes. Our safety stock of 20 boxes gives us 66.67. For question number 3, this one's actually fairly simple. We know that we're going to need 2,400 boxes per year. And we know that our EOQ is $8.95. So to find out how many orders per year we will need to make, we simply take D divided by Q star. All right, let me make that a little larger so you can see it. So we say D divided by Q star, which is the annual demand, divided by my Q star. So we're going to need to make approximately 2.68 orders per year. That means that we're going to need to order probably about every 3.5 months, maybe every 4 months. Okay? Now, the next question says, what is the total annual cost? And be sure to include the cost of the actual boxes. Well, there's two costs here, right? The first is the total actual cost. Now, if our EOQ is $8.95, then we look where $8.95 is and we get $53.67. That's half the equation. So for the first half, we're going to say that this number equals $53.67 because we have the total cost at the EOQ of $8.95. However, we also have to think about the cost of the actual boxes. We know that we're going to order 2,400 boxes a year and they cost us 20 cents. So that's going to be equal to 2,400 times 20 cents. So the boxes themselves cost us $480. We simply add those two numbers together to get the total annual cost. Now, this last one can be a little bit tricky, but it doesn't have to be if you'll just follow along. So let me make this where it's all on one screen. Your supplier has offered you a deal. She's going to give you the boxes for 15 cents if you will order at least 4,000 at a time. Is this a good deal? Why or why not? So let's take a look at that. All right. All you have to do is change the cost of the boxes from 20 cents to 15 cents and then see where your EOQ is. If the annual cost drops at 4,000, in other words, if at 4,000 boxes the cost is lower than where you are now, then you'll know you've done a good job. So let's figure that one out. So we're going to take the annual cost per case from 20 cents down to 15 cents. And we see that our change here has gone down to $406.95. Well, we're moving in the right direction. But our EOQ has gone from $8.95 to $1,033. Now, let's increase our numbers. I'm going to take all of these numbers here, the last three, and simply increase them until we get to 4,000, which is what she says we have to order in order to get that price point. So at 4,000 boxes, our annual cost is going to be $96. Before, at our EOQ of 20 cents, it was $533.67. So here we order 4,000 boxes is $126, right? Okay. But now we have to order 4,000 boxes at 20 cents. So that's going to be equal to 4,000 times 20 cents. When we add those two numbers together, we can see that we're better off by not taking the deal. So let me go through that one more time with you. Okay? All right. So here's where we are. We know that our EOQ is $8.95. We round that number up to the nearest whole number. That's because our cost is 20 cents per case. We get that number from the cost here and here. Now, at $8.95, it's going to cost us approximately $53.67 to order the boxes and hold them in inventory. That's this row right here. Okay. Plus the actual cost of the boxes, which we calculated at 2,400 times 20 cents per box. When you add those two numbers together, you see that the total cost is $533.67. Your supplier has said that if you'll order 4,000 boxes at a time, she will sell them to you for 15 cents a box. Now, all you really need to do here is take this number, the cost per case, change it from 20 cents to 15 cents. And you will see that your EOQ is still well below the threshold of 4,000 boxes. Your EOQ now is 1,033. This is where you have minimized your cost at 1,033, somewhere right in here. Okay? In order to do what she wants you to do, however, we projected it forward to 4,000 boxes. The problem here, of course, is that you've got so many boxes that you've got them running out your ears. You only need 2,400 a year. This means you're going to place an order once every year and a half. So this is way too many boxes, and you're having them in the way. They're just stacked up everywhere. It's costing you approximately $90 per year for you to stack all these boxes. You don't have room for them. They're getting in the way. That's lost productivity. So that cost is $96 plus the other cost of ordering the inventory gives you $126. The actual boxes themselves are going to cost you $800 a year versus the $360 that you had before, for a total of $926 versus the $533 that you had before. So you're better off not taking the deal. Now, I know that we've jumped around a lot on this video, but if you'll go back and watch it again, follow through with each of the steps, you should do just fine. And by the way, the EOQ model that you built, you can use on the next test. So hang on to it for test number 3. Hope you enjoyed the video. Have a great day.